artificial what? This talk I've been given for a while. It's becoming more and more philosophical because. So maybe I'll jump ahead. So artificial intelligence was extremely unpopular until recently. In fact, I was in this field in the 80s. And some of the people who were in the field with me physically removed any reference to artificial intelligence from their resume. It was that unpopular. And in 2017, guess what? Everything is artificial intelligence. Very soon, the coffee machine will have a sign on it with the AI inside. So it's kind of interesting, except I'm not sure anymore what is the thing that is artificial. So anyway, this is me. If you haven't seen this picture, Tammy and the people who know me, this is me in the 80s working on AI. And that's the book on artificial intelligence, and that's also translated in Chinese. So this lady who co-wrote the book with me, one day she asked me, "Are you afraid of artificial intelligence?" Because now there's, Bill Gates, Stephen Hawking, everybody's worried. And I replied, "I'm afraid it will not come soon enough. I'll explain now why I'm not afraid of it and why I think we need it." So I always start with this picture actually because I really like the pictures of the early computers. There's all women programming them. That's part of history that's been forgotten. It's being rediscovered slowly. I just love these pictures. Anyway, the reason I start from back then is because from the very beginning, your timing, right?
Yes.
From the very beginning, they were called the electronic brains. So to me, artificial intelligence was born with the first computer. The very first computers were presented by both the scientists and the media as the electronic brains, as something that eventually will be able to do everything we do. So there's lots of these things you can find where they are advertised as the electronic brains, the giant brains. The very first book written on computer science is titled Giant Brains. And then in 1956, John McCarthy organized the first conference titled Artificial Intelligence. Actually, the name was already in the proposal in 1955. So officially 1956. To me, between 1956 and today, the number one protagonist in artificial intelligence, to me, has been Moore's law. Why I say this? Of course, there has been progress. Of course, there's been a lot of new techniques introduced. But the fundamental ideas, you go back to the 50s and the 60s, the fundamental ideas were there. What was not there is the computational power to do something useful with them. Like today, neural networks are very popular. Well, neural networks were invented way back then, except a two-layer neural network was intimidating. And today, we have multi-layer neural networks. In fact, there's a chip that allows you to build, I think, 150 layers. So to me, Moore's law has been the real protagonist. Anyway, today we live in the age of deep learning. Probably everybody's heard the term deep learning. And that's something that started developing in the 90s. You can pick your favorite inventor of this technique. I think most people would focus on these three names, Yann LeCun, Geoffrey Hinton, and Joshua Bengio. And they came out between 2006 and 2012 is when it develops very rapidly. In 2012, there's a major achievement that I will not explain, but 2012 something happened in recognizing images that dramatically lowered the error the machines make in recognizing images. And that's why today you have auto-tagging and stuff like that on social media. Well, there's many people involved. So today is the state of deep learning is the state of the art for, in general, pattern recognition, for recognizing images, speech, behavior, patterns in human behavior. Trivia, it's kind of interesting that all the protagonists of the revival of neural networks, none of them was born and raised in the United States. And Don't ask me why. It's just a trivial. One day I was writing this list of people, more or less chronological, and I realized there's nobody actually born in the United States. And you have to give credit to these people, because as I said, there was a time when artificial intelligence was unpopular. It was not the right thing to do in academia, and neural networks were particularly discriminated, okay? And these people believed in it and kept publishing papers and so forth. Okay, so this is the age we live in. Of course, you all know this, all these things have become common practice. One of the first big achievements that made the headlines was when this system learned to recognize cats on YouTube using 16,000 processors. That's not the detail. And then that's another record. So today, with that chip, you can do 152 layers, which in the 50s would have been unthinkable. Even in the 90s would be unthinkable. Lots of startups, investment. These are the big companies investing, acquiring startups, and then these are some of the startups with valuations that are sometimes staggering. One of the most publicized recent achievements was when AlphaGo, developed by DeepMind, which is owned by Google, beat a Go master. During my trips in China, I learned that they don't know what Go is. It's called Wei Qi in Chinese, and we call it Go. When Google does it, everybody talks about it. Actually, there's a long history of artificial intelligence programs beating Go masters. So this is something that started before 2016. And 2016 is when Google did it, and this was widely publicized. Why? Because Go is significantly more difficult to play than chess. So it involves more than just linear algorithm. Oops. So all this progress have generated some anxiety, and people are much more intelligent than me and much more competent, are afraid of what artificial intelligence could do. Same progress in robots. Some of these are just for show, like that Japanese scientist is famous for doing anthropomorphic robots. That's, you can probably tell that's him. That's his robot twin. But there has definitely been a lot of progress, even in the dexterity. That's one of the favorite YouTube videos last year was 2 years ago, was the robot at UC Berkeley that folds towels. Picks up the towel and folds it, right? And that's a kind of dexterity that, again, when robots were invented was unthinkable, and today it's happening. So, and then last year, something actually very interesting happened. They used neural networks to do art. And so now so to me, it goes back to the article published by this guy and another guy, and this gentleman really figure out how to have neural networks do things. This is the other article. So you start having this kind of pictures made by the machine, and Alexander Mordvintsev at Google, I think it is Google Zurich, is in Switzerland, I think. He came up with the term Inceptionism as a new, a new kind of art. And these are some of the examples. And then they had an auction in San Francisco, and I believe one of these was sold for $1,000 something. I'm not sure what they bought, because it's just an algorithm. You can run it at home, and we will do the same thing. Then there's others. There's, this program simulates an artistic style. This is a 3D printed Rembrandt portrait that was done by the machine based on the Rembrandt style. And the same has been done in music. There's automatic composition, and so forth. And the interesting thing is that some of that art actually came from AI scientists, not artists, AI scientists who wanted to understand how does it work. Because the deep learning mostly is using this convolutional neural net. If you study convolutional mathematics in general, you understand why there is a term convolution. So it's difficult to understand what they do, but then they work. And in practice, they do recognize images and they do recognize speech, but actually it's not really clear why they work so well. So AI scientists have been studying the neural networks that they use to understand why does it work so well. And in doing that, some of them came up actually with art. And I find that to be an interesting footnote to what is going on. So for example, very recently, I actually just read the article on the plane. Wojciech Samex, I really forgot where he is, I think he's in Germany. He wrote a paper on this method that he calls deep tailored decomposition, which is a way to figure out what did the neural network do. I mean, we know what the result is. We recognized a cat. But how did he do it is not really clear. The job of an AI scientist is an extremely boring job in a sense. It takes a lot of patience to tweak those layers and tweak the algorithm you use until the network learns what it's supposed to learn. But it's not really deterministic. It's not like you know that if you do this, the network will learn to play Go. It's really a lot of tweaking. It's actually art in a sense. So anyway, so of course then people started speculating that if machines are getting so good at so many of these things, eventually they will become so intelligent, so much more intelligent than us. Yeah? That's where we are. And probably you heard the name Kurzweil, there's other people before him, prognosticating a future in which machines are smarter than us, and we might lose control over them. So first of all, I'm not afraid. I think these are wild exaggerations. There's a number of reasons why. I will just mention a few. And the second point is that it gets sort of counterproductive, because actually intelligent machines can do a lot of intelligent things that we need. And if we just get very scared about the whole thing, we might actually lose something that would have been very useful. So the first comment that I keep making is that machines do a lot of useful things, but we prepare the environment for them. Okay? The self-driving car in the messy traffic of India or Tehran doesn't do much. In the very structured traffic of Singapore, it makes sense. If you're familiar, Singapore is one of the most disciplined countries in the world. And in Sunnyvale maybe, although I was behind it when there was a car parked in the middle of the street, the Google car didn't know what to do. Eventually you could see that the co-driver eventually just, did something illegal, okay? Anyway, so we structure the environment. We fill the world with signs, not only in traffic, in everything. There's rules and regulations. So when you have a very structured environment, it gets a little easier. It gets a little easier for idiots to do intelligent things. Therefore, it gets a little easier also for a machine to do it. So first thing, you have to structure the environment in order to have a machine that does something. Recognizing a cat is great, but it took 16,000 processors. I mean, how long does it take for a mouse to recognize a cat? AlphaGo, great achievement. It came much earlier than anybody expected it. I think a lot of people predicted it would happen, but it came earlier. Great achievement, but again, it's using things. First of all, it needs a large data set. I think I have a slide about this. Neural networks do nothing if there is no large data set. Somebody is to prepare this huge data set, and then hopefully somebody builds a neural net and can learn something out of this data set. So somebody to prepare a data set of 150,000 games. Then it's using Monte Carlo tree research. I don't even know how far back that goes in time. It's an old technology. And reinforcement learning was Marvin Minsky's thesis in 1954. Okay, so, major achievement, but the concepts actually been around for a while, with countless improvements of different, but the fundamental ideas were there. And my point is always, okay, AlphaGo plays Go very well. What else can you do? You can do a lot of things. In fact, you can do an infinite number of things. Most of them you don't do too well. In my case, I do almost none of them well, but I can do a lot of things. AlphaGo, one thing. I did a little calculation of how much power AlphaGo consumes. 440,000 watts is my estimate. My brain, 20 watts. Your brain, 20 watts. Okay? So imagine 440,000 watts playing Go with a 20-watt machine. Are you impressed by this monster or by this humble human brain that with 20 watts can win what? 1 out of 3 games, 1 out of 4 games? You know. So that's why I call it reality check. You know? So 20-watt machine. When are we going to have something like Einstein? You get the point.
Yeah.
And actually, if you plot a diagram, you realize that these achievements in AI come with more and more and more power, right? You need more and more computational power, which means more and more watts. But that's not true of our brain. It's not like in order to study relativity, I have to add more I mean, the brain somehow, our human brain can learn something and apply to so many other fields and learn software and learn general relativity. So are we moving in the right direction? That's a fundamental question in my opinion. Most of the achievements come from supervised learning. That's only as good as the expert. Supervised learning means somehow there's a reference point, which is human being, usually many human beings. That system will be only as good as the reference point. Now, that's actually important. Most of these achievements have come right after somebody built a large database. That's not a coincidence. You know, there's been chess, big news, IBM's machine beats whatever master in chess. But that happened after somebody created this huge database of chess games played by masters. And same with the Atari video games, if you heard of it, I think it was 2013, when the machine started playing Atari video games better than the professionals. Happened right after somebody in Canada, I believe it was in Canada, created this huge database of Atari games played by experts. And same with AlphaGo. And ImageNet. I told you in 2012 there was a spectacular improvement in the speed, in the accuracy of image recognition. It came right after Faith Lee created ImageNet, a large data set of images, which now has 1 million images. So, you know, that's my reality check. There's certainly progress, but let's put it in perspective. And then the people are afraid of artificial intelligence, of the singularity, and so on. I mean, we have lived with non-human intelligence for a long time. Those are two of my favorite examples. You know, non-human intelligence, a bat. How many of you can fly in the dark, avoid obstacles, and capture insects, and land upside down on the ceiling? But bats do it. And you know, we invented machines like the clock. Her clock is doing something that no human can do. It's keeping time. It knows exactly how many minutes I've been speaking. So, so the message is, the number one self-driving vehicle is the plane. I took a plane from New York to San Francisco. That's a robot. It's only completely automated. So now there is a lot of progress, and I'm not denying it. And it's extremely useful. There are many things that we don't do that we should be doing. Favorite example, medical images. There are millions of medical images out there. They've been viewed by only one doctor. Imagine deep learning scanning all those medical images based on the most accurate recent knowledge and telling you something that your doctor originally didn't see. So, my message, that's why I replied to her when she asked me that question. I'm not afraid of artificial intelligence because I can see the limits. You know, 'cause I can see what the status really is. I'm afraid it will not come soon enough because actually it could be very useful. All these things are already useful, right? Recognizing images and speech and so forth. I'll leave it there. If there's any question, I can answer depending on where the questions are.